So yeah, this is what's new in Airflow 2. If you've seen this talk before, we gave it a few weeks ago at the NYC virtual meetup. It has been updated, so there will be some new content in it, so don't worry, it's not just a repeat. So who are we? We are Tomasz, Jarek, and Kamil from Potiuk in Poland, and then myself, Ash, and Daniel, and Kaxil. We're everywhere, and we work for Astronomer. All of us are committers to Airflow. And I've been updating the wrong slides. There we go. Sorry about this, everyone. Technology is wonderful, except when it doesn't work. So yes, we also have some announcements to make. We have just invited a new committer, QP Queues, who works from Script and has done some sterling work on Airflow. He's now a committer on Airflow. So welcome, thank you. And perhaps more importantly, we also have just invited Tomasz, Daniel, and Kamil to join the Airflow PMC, the Product Management Committee. They've been involved with the project for a long time, so great work. Glad to have you aboard, and look forward to seeing you continue contributing to Airflow. We have a surprise extra session that we've kind of snuck in. We have an Ask Me Anything session with some of us, not all of us can make it. This is tomorrow, late Pacific time, or early Friday, or normal time Friday for kind of Asia time zone, hosted by the Bangalore meetup. This will be no presentation, it's just a kind of Q&A session, so if you have any questions that don't get answered today, or that you want to ask us that's kind of not related to this talk, tomorrow's your chance. So join us there. So, first one, high availability. This is AIP 15, which is supporting scheduler running high available, so more than one scheduler, for performance, scalability, and resiliency reasons. This has kind of been a project of mine for kind of a month or two, kind of ticking away in the background, working on it. How does it work? So, fundamentally, the design we've gone with is active-active. Every scheduler can do the job of every other scheduler. There's no special, there's no leadership election, there's no kind of coordination needed between the schedulers outside of the existing metadata database. So your Postgres, your MySQL, that's the only thing you've got to run. That already exists, so not increasing the operational burden by having to include console or Zookeeper or anything with the consensus protocol, because if we can avoid that, it makes running Airflow easier. We're going to use the row level locks, so kind of select for update. It seems to work. We're going to test it to destruction and make sure it does actually work. Everyone likes diagrams. This one is not a particularly interesting one. Basically, everything goes through the central SQL database. In my testing, this hasn't been a bottleneck yet. I'll get on to some figures shortly. What's to do? So, kind of the big high-level ones are separating the DAG parsing from the DAG scheduling. So currently, as of Airflow 110 and the kind of the mainline branch, Airflow won't schedule a task until that task has been parsed by the parsing process. It's not in the same process anymore, but until it has been parsed and sent back to the scheduler, it can't actually be scheduled and run that task. So the first one is to break that apart. The other thing we've got is what we're calling fast follow, which is at the end of a task, when it's finished running it, we've already got the DAG definition there. We can look at the downstream task and see see if we can like go, okay, I can put that one in scheduled. So yeah, those two ones have been, I'm not going to say completed because it's not perfect, but it works. and there's a bit more testing to do. The last big thing is to test it to destruction. I've been discovering all kinds of race conditions in Flask App Builder and in Celery and stuff, and some of them was like, it doesn't matter, but we're testing it. This will be coming soon, very soon. Performance, this is the one that everyone cares about. I'm sure we've all kind of thought it, which is sometimes the Airflow scheduler is a little bit slower than it should be. So what we're measuring when it comes to kind of this HA work is something we're defining as scheduler lag, which is the amount of time wasted not running tasks. So if this was 0, one task would finish and the next one would start straight away. We're never going to get it to 0, but we want to get it as small as possible. Roughly speaking, it's the start date of one task to the maximum of the end date of the upstream task. So as soon as my upstream task finished and I start, like how quickly could I start it if Airflow wasn't getting in the way? And in all these tests, the tasks are actually run. They don't do anything, so they're like, it's echo true, or echo test, I think I was using. So the tasks are running, they just don't do anything important, because for scheduling, how long the tasks take is irrelevant. Preliminary performance results. I say preliminary because this code is not even public yet. It's kind of in my hacky branch. It's littered with to-dos of, hey Ash, you need to fix this. But the results are promising. So for that kind of performance metric, so on 110, this case here where we have 100 DAG files with 1 each, and 10 tasks per DAG, so kind of like a lot of fairly small DAGs, 4 workers and 64 parallelism. It went from 22 minutes down to 48 seconds. Seeing that numbers just makes me cringe that we haven't done this earlier, because how did it take 22 minutes to run 1,000 tasks that were doing nothing? So that's total runtime, and also the lag. So the figures are lag, standard deviation of that, and then total runtime. So 54 seconds down to just under 2 seconds, which is massive. That's for a kind of a small test case. And then for a larger benchmark, this is running 20,000 tasks. So this is one DAG file, one DAG in it, 20 tasks in that DAG, and it's running for 1,000 days, just kind of catch up from, what's that, sometime in 2016 or whatever it is, not important. 20,000 tasks, 30 workers, quite a large scale one. So on 110, this took 1 hour 30, 90 minutes, and down to about 18 or 20 minutes. The key bit being there, like, hence why this is all preliminary. That star on the 3 schedulers line, where it's down to 1 minute 50, 1.5 seconds of lag and 12 minutes. Some of the tasks failed. There's still a bug somewhere where a task is getting requeued when it shouldn't. So not there yet, but looking very promising. I'm sure there's going to be lots of questions about this. The code is coming soon, except for the fact that I'm going on paternity leave the end of next week for 6 weeks, so may not land before I go. We can have more on this later. Next up, we have Kaxil with DAG serialization.
Thank you, Ash. I'm going to talk, first of all, congratulations to Tomasz, Kamil, and Daniel. So I'm going to talk about what I have been doing since last 6 or 8 months, to be honest. First of all is DAG serialization. So currently when you install Airflow, both the web server and the scheduler need to parse your DAG files and create the DAG bag out of it. This makes a redundant work and also consumes more, also means that the scheduler and the web server needs more resources when it does not need to. So with DAG serialization, we have separated this, and so the scheduler needs to do all the parsing work. It will parse the DAG files and upload it to the metadata base. The web server then reads from the metadata base and shows it in the UI. So the figure on the left is what you will see with the stock 110.10 version, and the figure on the right is what, if you turn on DAG serialization, what would happen. So the metadata base over there would store the DAGs. parsed and converted to JSON serialized format, and then the web server would read it from there. So the task we have completed as a part of DAG serialization, and we also did some optimization work. So first of all, this web server is stateless. It does not need to pass the DAG files anymore. They are already the scheduler already serializes it and uploads it to the web meta database. As I said, the next important bit is lazy loading of DAGs. So previously, whenever the web server would boot up, it needed to load all the DAG files. So imagine if you have like hundred or thousands of DAG files, it would take that amount of time to load your web server and start serving requests. Um, that's just not great. So with lazy loading of DAGs, the web server would start with empty DAG bag, and it would only load the DAGs on request. So whenever you click on a particular DAG on the home page and it needs to show you the DAG structure, it is that when it pulls the DAG from the web server. Deploying new DAGs to Airflow no longer requires restarts of the web server. Like previously, you had to keep your DAGs in sync for the web server, the scheduler, and the worker. Now you at least don't need to do it with the web server. The web server don't need those DAG files. We have also added the feature to use the JSON library of choice. The default library that we use is the stock JSON library to serialize your DAG files, but you can also change it to use UJSON or iJSON, for example. This also paves way for DAG versioning and scheduler HA. So the work Ash has been doing on scheduler HA is on the serialized DAG representation. So that's already, the work is already happening. So the task that we are still working on currently for 2.0 is decoupling DAG parsing and serializing. You might have heard Ash already talking about it as a part of scheduler HA work. So that is already taken care of. Scheduler will fetch DAGs from DB. So what we are planning is to create a separate component that might be called a serializer or a DAG parser. The DAG will be passed, serialized, and saved to the DB by that component, and the scheduler will just fetch it. It is no longer responsible to serialize the DAGs and storing it in the database. So it does the meaty part, which it should do. The only thing it should do is schedule the DAGs at the right time. This should reduce the delay in scheduling tasks when the number of DAGs is quite large. The second part that I have been working on very recently, and we are still open sourced many things about it, is DAG versioning. So let's talk about the current problem. So the current problem is whenever you run a particular task. Let's take a look at this example for yeah. So on the left is your DAG file. You have two tasks and they have run to completion. Now you add a new task to your DAG file. What happens if you check the graph view for the older DAG run? It would show the new task, but that would have like blank borders, like no state. The problem lies because this task did exist when the DAG actually ran. So the DAG structure is inaccurate for that particular DAG run. Um, Inversely, if you think about it, let's say if you have three tasks right now and you update your DAG to just you remove one of the tasks and you just have two tasks right now, you will see that you would just have two tasks, and even in your previous DAG run, so it would get difficult for you to check the logs for that deleted task, and the representation of that DAG is incorrect. We want to solve it as a part of the DAG versioning. So the goal for DAG versioning is, oh sorry, wrong button. Yeah, so the goal for DAG versioning is to improve the logging bits. So you will be able to always see the correct version of the DAG, even in your previous versions of Dagger. So where you can click on that particular task and check your logs, for example. uh, the other thing we want to address it as a part of DAG versioning is having baked in maintenance DAG to clean up old DAG runs and associated serialized DAGs. We have also seen the cases where the task instant table can get massive, even the XCOM table. So we want to have maintenance DAGs to clean up those old versions, and that would be configurable. So you can configure the number of records you want to remove. And the important one, the graph view should actually show the associated version with that diagram. It should not show the latest version. um, that's that's it. Passing this to Kamil for his awesome performance improvements.
Uh, mm, uh, Hello everyone, I'm Kamil Bregula, a software engineer at Polydia. I wanted to improve performance of scheduler as we're working on introducing new solution that will improve performance, and I want to focus on improving current code to make current installation after the upgrade more fresh. So I review each component in turn. I began with the preparation of the tools that will allow me to check the performance. I call them perf kit. There are decorators and context managers that allow us to check database queries in a given block of code. It's integrated with Python, so now if you want to test case queries in the test case, all you have to do is run a Python switch additional option. Mm. In some cases, the my scheduler was loading DAG files to include callbacks. Unfortunately, DAG files loading DAG files is time consuming. Sometimes it takes up to several seconds. The scheduler cooldown starts new task at this time. Note is step has been moved to Docker processor. This processor had Docker already loaded, so we don't have it to load the DAX file again. Mm. Air, mm, Airflow is deployed in different environments. Some users install Airflow locally, but use a managed database in the cloud. Some users have to comply with the strict regulation and encrypt the database connection. Some users have a different components arrangement on many machines. In each situation, there is one bottleneck: round trip time. To improve the airflow performance, in such case, we try to limit number of queries to that database. We have already managed to limit the number of queries in some components. However, the exact times might vary depending on each deployment. When we improved the performance, we wanted to avoid change that might have a negative impact. That I have created some additional tests that perform operation in a context manager that count the queries. This way we can catch up change that have a potential negative potential impact on airflow during code review. Such tests are critical in the open source project like Apache Airflow because contributors come and go, and the technology is not always passed on. Next person is Jarek.
Okay, so I'll be talking about REST API, though I'm not the main person responsible for developing it. It's actually Kamil who just finished talking. And once again, congratulations to the new PMC members, Kamil, Tomek, and Daniel. It is really well deserved with the hard work of those guys. So this part of the of APIs that we are going to have like really modern new APIs, ones that you expect in 2020. So they are all based on Open API specification. We have really nice Swagger UI that you can browse and test and run the UI. Plus, you can have we will also have a set of clients written in like Java, Python, Go, and JavaScript. Those clients will be automatically generated from that Open API specification, and you will be able to use it just to interact with Airflow very, very easily in whatever language you like. There are even a few more languages that we can use, but and we'll wait for you to expect some of those. What is important there, we have a lot of help from Ephraim and Amir, who are our outreach interns. Jamal, in her talks in a few days, she will talk about the diversity and like our community being more welcoming, one of the most welcome communities in Apache, I guess. So we are participating in outreachy program, which is like Jamal will tell more about that, but we have interns, they are helping, and they do amazing work. I must say right now, together with Kaxil, we are mentoring Ephraim and Amir, and Kamil is leading them in implementation of the API, and we are, I think, months ahead of schedule, or weeks at least. So that's a good thing for APIs. As you see, the progress is quite well. Green, as you may expect, is done. Some things are still blocked, waiting for something. Some things are to be done. And as you see, the progress is like we are maybe not nearly there, but it's coming there. My beloved part is like CI environment and development environment. This is what I mostly work on. So we moved to GitHub Actions completely right now, including Kubernetes test. We have a very easy way to test Kubernetes tests locally. There will be soon an updated Breeze video showing all that. So I hope finally you will. I will refresh that video. We have some quarantine tests, which are being fixed, not yet there, but we are going to fix it soon. We have much less CA image for development environment to run. We moved a lot of integration out of the image. And we are ready to implement some of new things like automation of system tests. Development environment is like, I think it's fairly complete. It was developed for quite some time. We have Breeze, which allows for unit testing, package building, release preparation, Kubernetes tests running. Refresh videos will be there. They're not yet there, but they will be. And soon we are going to move to code spaces, VS Code. This part is not that interesting for users, so I'll skip it fairly quickly. But this part is and should be. So we have released Backport Packages. Backport Packages allow you to use the great and awesome and like big number of Airflow 2.0 providers in Airflow 1.10. They are packaged per provider. We have 58 packages for 58 providers. They are only working for Python 3.6 and above, which is very good news. They are automatically tested on the CI that we have. And in the future, again, we are going to automatically test them with automated system tests. This is something that we are working on. And quite possibly, this is something that we might discuss on the upcoming talk on Thursday or Friday, depends which time zone you are. The one that Ash was talking about, whether we are going to split Airflow 2.0 into providers from day one. I hope so. And there will be talk about migrating to Airflow backport providers from Anita Fronczak on Thursday, July 16th at 4 a.m. UTC. It's quite early for most people, but for other people, it's late. It's like time zones. And you can watch there how to use backport packages to migrate, to prepare for migration to 2.0. We also have support for production deployments, which is the production image. Production image is like already beta quality. Last time it was like alpha quality. We started with some bare image and listened to the cases from many users we had. And we integrated with the Helm Chart. So the Helm Chart that we have now is automatically using this new production image during testing even. We implemented some of the feedback. As you see, there is a project in GitHub, which like the progress is there. As you can see, there are some done things. We still work on Docker Compose, which will be there. And I will talk more about that on Tuesday, July 14th. There is a whole talk I have. Also early in the morning for some, late for some others. You'll find it in the program. Time zone is an interesting thing for this project, for this summit. What's new for Airflow and Kubernetes goes to Daniel.
Hello, everybody. Thank you so much for having me, and thank you all for this awesome opportunity. Yeah, so let's talk a little bit about what's coming and what has recently come for Airflow on Kubernetes. So about 2 years ago, we... sorry, wrong button. So let's talk. The first thing I wanted to talk about is KEDA Autoscaling. And first, before we can talk about KEDA Autoscaling, we need to talk about the Kubernetes Executor. And the Kubernetes Executor was released about 2 years ago, and the response has been fantastic. There are so many companies running it in production. It's the first real auto-scaling story for Airflow, where previously users had to kind of statically allocate how many Celery workers they had. And now, instead, using the Kubernetes API, you just launch this one deployment, and it auto-scales out based on the number of tasks and scales back to 0 when you're done. And while there's been like a lot of very good there's been a lot of very good usage of the Kubernetes Executor, which has also led to a lot of very good feedback about the Kubernetes Executor. And one thing we found in terms of feedback is that the Kubernetes Executor, while it works really well for small to mid-sized deployments, when you start getting to hundreds or thousands of parallel tasks running, this can get really expensive because each task has to launch its own Airflow. So suddenly you have 1,000 unique pods running at the same time. And that also leads to a non-zero amount of startup time because you have to start the container, you have to start the Python interpreter, you have to start Airflow, and then run that single task. And so this kind of has created a pretty interesting pros cons versus the Kubernetes Executor and the CeleryExecutor, where the Kubernetes Executor has dynamic allocation and the ability to modify each environment on a per task basis, while the CeleryExecutor has immediate SLAs because the workers are already running and better efficiency because you can run multiple tasks per worker. And so recently, myself and Tomasz have been looking into how do we create a story that merges the best parts of the Kubernetes Executor and the best part of the CeleryExecutor. And we found a solution in a system called KEDA. Now, KEDA is a CNCF project that is part of the Kubernetes environment, and it's the Kubernetes event-driven autoscaler. And it's essentially a framework that allows you to build an autoscaler based on any random event. And what we ended up building was an autoscaler based on Postgres. So now we actually donated this to the CNCF, where it's its autoscaler where you give it a Postgres query, and based on the result of that query, it will know how much to autoscale. So in the case of Airflow, it would base on the number of running and queued tasks, and then divide that by the parallelism per worker. So in our example, let's say we start out with an empty Airflow instance where no DAGs are running. So we have 0 running and 0 queued tasks. So now we have 0 workers. The second we add a single task, KEDA is able to say, okay, I need to create one Celery worker for this task. And what's especially great here compared to the Kubernetes Executor is if we have one task running at a time, the worker is already running. So it's able to do a fast follow where essentially there's no startup time. There's no launching a new task. The worker is already up. It's able to pull in, and because of how GUnicorn works, it might already have a process running that can take in that task. And then as you scale up, now you start to really see the efficiency, where if we're running 40 tasks instead of having 40 pods, we instead just have 4 Celery workers. And this is especially valuable if you can have a lot of tasks that don't require a lot of computation resources, such as if you're launching a Spark instance, if you're launching a Spark job, and Spark is doing all the actual heavy lifting instead of the Airflow worker itself. Now, where this becomes especially cool for the Airflow on Kubernetes story is that historically, queues were pretty expensive. So if you were running Airflow with the CeleryExecutor, you essentially were limited by how much complexity you wanted. So if you're running 10 separate queues, you now have to do allocation and decide how many workers you're going to put on each of those queues. But now queues all scale to 0. So you can create 100 different deployments using the Kubernetes API and auto-scale all of them with KEDA. And now you can actually have this kind of separation of complexity where your higher level data scientists and data analysts only need to know which queue to send a task to, rather than having to worry about what Kubernetes configurations to give. So you can actually create a queue that has access to GPUs for TensorFlow, or a queue that has extra memory if you're trying to run a Jupyter notebook. And so you can create any number of configurations, and they don't cost you anything because they all scale to 0. And there's one other really cool feature that is coming out in terms of the Kubernetes Executor and Kubernetes Pod Operator. This is actually coming out in the upcoming week in Airflow 1.10.11, and that is the ability to template your pods using YAML and JSON. So historically, with both Kubernetes Executor and Kubernetes Pod Operator, users were given a number of parameters that they could define, like things like labels or image or any of these other things that would then be injected into the pod that's running. But what we found is that the Kubernetes API is so expansive and so quickly changing that it's so much more efficient to give the users the actual kube level access to essentially create a template for all of the pods they plan to run. And so, let's see. So what will happen is that in both the Airflow.cfg for the Kubernetes Executor and in the operator itself for the Kubernetes Pod Operator, we're adding a pod template file parameter where you can actually point it to a YAML file that it will then convert into a pod and essentially merge in anything that's required by Airflow. And a huge thank you to David Lum for actually adding this in. And it was a pretty monumental effort to backport this to 1.10, but we're pretty excited to release this in experimental mode next week. I would also like to talk a little bit about the official Airflow Helm Chart, which is actually available now on the master branch. So you can actually, if you want to, we will be talking about this a lot more on Friday in our tutorial, but if you want to start playing with this, you can actually go to the Airflow master branch, go into the charts directory, and install Airflow via Helm. This was actually donated by astronomer.io, and this is very heavily based on the chart that we've been using for a very long time on real Airflow customers. So we've run this at scale. We've run this on a whole host of different cloud environments, and this has been a part of both our enterprise and cloud offerings. We recently have made this Helm 3 compliant, which in our tutorial, we'll talk a bit more about why that's important. And it has KEDA Autoscaling in it, where you can actually, using the Helm variables, turn on the autoscaling. This chart will also actually significantly simplify the testing of Kubernetes Executor and just in Kubernetes in general. And that's something Jarek had mentioned earlier, which is that we recently actually fixed this into our Kubernetes CI/CD. And where that's really important is that in all forms of stress testing or system level testing, now we can actually create a number of tester DAGs. So we can create a DAG that launches 10,000 tasks, or DAGs that use all of the executor configs in the Kubernetes executor, and we can ensure that they're actually working in a real Kubernetes cluster. And next, I believe, is Tomasz to speak about functional DAGs.
Yes, hello everyone. The next interesting feature of Airflow 2 is going to be about the way we are going to define DAGs. So let's start with current state. As you can see, here is a simple DAG where we define the function, get cat pictures and save cats, and then we convert those functions to the Airflow task using Python operators. And in this case, we have a lot of Python operator boilerplate code, and then we have to define separately the order relation, which is done in the last line using the chain operator, and then we have to define the data relation, which we do using the Jinja template. So we are telling the Airflow that the output of the first task, get task, has to be interpreted as an input to the second task. And that means that we are writing Jinja strings by hand, which is quite error-prone process. And what is going to change in Airflow 2 about this Python operator and writing DAGs like this one is that we are introducing a new way to convert a function to an operator. And this was introduced in I31, Airflow Functional DAG Definition, which was proposed by Jarek Kaxil. I will just say it in a moment. And what we introduce is the task decorator. So all you have to do is to define a function, just a normal Python function, and add this task decorator. And once you invoke this function within the DAG context, it will behave as a Python operator. And what you can see is that you are just normally passing arguments to this function. And what is more, the result of the function can be used in the another function, like in normal Python. And that means that we are simplifying the way of writing DAGs, and we are making the data and order relationship the same, because Airflow under the hood will resolve that in this DAG case, the get cat pictures task has to be executed before save cat. So the I31 proposes easy way to convert a function to an operator. It's really easy. We give you the simplified way of writing DAGs using custom Python callables. This could help you also with simple custom operators and things like that. And we give you the pluggable XCOM storage engine, which allow you to use a custom XCOM class. So you can override these serialized and deserialized methods. And that means that you will be able to store and retrieve, for example, data frames from GCS or S3 buckets, and without any boilerplate code. So we are reducing another layer of repeating ourselves. If you want to learn more about the I31, please join Jarek Kaxil on 10th of July during the Airflow Summit, because he's going to give a deep dive into the origin of the idea and the exact implementation behind this I31. And next thing is smaller changes that are coming to Airflow 2, and this will be Ash.
Great, thank you. We are running out of time, and I want to leave some time for questions, so I'm going to run through these pretty quickly. We can ask more about them later in the next session. Connection IDs have to be unique. They didn't used to be. See the issue number if you want. Python 3 only. Python 2 hasn't been supported officially since the start of this year. Airflow 2.0 will only support Python 3. If you haven't yet upgraded, you're about 6 months too late already. Upgrade now. the RBAC UI, role-based access control. Currently in 110, this is enableable by a flag. That's the only UI. The only real change is the data profiling and chart sections have gone. Sorry about that. Too many security concerns to keep them in core. You can add them back as a plugin. Someone hasn't done it yet, but it's doable. The big question, the one that everyone wants, I'm sure, is when can we get Airflow 2.0? When it's ready. Airflow 2.0 is mostly around breaking backwards compatible changes. Not everything we've mentioned in this talk is going to be in 2.0. Some of it will be 2.1, some of it will be 2.0. There is a project board, milestone, a 2.0 milestone in GitHub. Once everything in that and some of the related changes in the 110.12 branch are done, we can release 2.0. People are running it in production now. It's better, it's faster. So really soon. Rough plan for how we're going to upgrade. Install the latest release. Run this command that doesn't exist yet. Kamil has started it. We haven't got it yet. Fix any warnings, then upgrade. Usual caveats about when you upgrade, apply, database upgrades, etc. Right. Questions. I don't know if we have a next slide for that one. We do. Questions. That time.
Probably one question, and if we don't get to your question, please do ask it in the Airflow Summit attendees channel. Ash, thank you for answering the number one question, which is when will Airflow 2.0 come? I am going to ask one of our shorter questions just for time reasons. So for AIP 31, are there limitations for data that can be passed between tasks?
I think it will be me to answer this question. There is in default form, there is a limitation of the XCOM engine you are going to use. In default Airflow, the data has to be JSON serializable. If you want to store more complex database, complex objects, you will have to use external storage, like I said, for example, GCS buckets. And then you have to use custom XCOM backend, so you provide information how the complex object has to be serialized and persist on the external storage.
I think to add to that, I just say the custom XCOM would provide an ability so that you can store something in S3, GCS, or anywhere. So it depends on how you want to use it.
Okay. I actually just got note that we can take a few more questions and dip a little bit into the break. All right, the next one we have is the meta database is taking a lot more responsibility now. The current vertical scaling need on the scheduler has moved to the database. We'll be requiring a larger database to manage 1,000+ DAG Airflow 2.0 environment. How are we making sure to test for DB locks at scale?
That's definitely one for me then. Hopefully, it's actually placing less load on the database. The way Airflow was written in the past, it was kind of doing a lot of the same work repeatedly. So hopefully, mostly with Kamil's changes to make sure we have fewer round trips, better query performance, plus rewriting large chunks of how that works, it should place less load on the database. We're definitely testing this. This is not going to get merged and released without extensive testing. It's a big change. It needs testing. We will see how we can do it. It possibly will be available available as an option or something. But yeah, we're testing it extensively. We've got a lot of test scripts to spin up, small DAGs, large number of DAGs, long running DAGs, big DAGs, small. Yeah, don't worry, we're testing this. Hopefully it'll be less load. I haven't seen any differences in my change, but I haven't got to the really big consistent 1,000 DAG runs every day kind of test yet.
Cool. All right, the next question, any recommendation about the deployment strategy for DAGs and Python system packages with KEDA, please?
Okay, I guess that one's for me. So one thing that's really great about the KEDA system is you get to treat it exactly the same way as you would the CeleryExecutor. So the way that KEDA works is that you can define your workers as a deployment, like using the deployment object in Kubernetes and just point the KEDA Autoscaler at it, and then it will just start to autoscale. So pretty much exactly the way that you would do a CeleryExecutor. So just create your workers. Maybe for Python packages, you might want to bake those into the Docker images. You can have multiple Docker images. So one example would be that you might want to have certain system level libraries if you're doing any C++ or Java work. And so you could have a KEDA queue that has those system libraries in it, and then you don't need those system libraries for any of the other queues.
Cool. All right, Daniel, I have another KEDA question for you.
Okay.
Is KEDA integration based on integration with Postgres or the target solution? What about MySQL? Is it planned to use the Airflow REST API?
I'm sorry, I can't.
Oh, all right, let's try that again. Sorry about that. Is the KEDA integration based on integration with Postgres as the target solution? What about MySQL? And is it planned to use the Airflow REST API?
So I personally did it with, I personally set it up to work with Postgres, and Tomasz created a MySQL. So Tomasz and I both worked on this. I worked on the Postgres scaler. Tomasz worked on the MySQL scaler. So KEDA will have support for both of those databases. I believe if you're using any of the other databases, you might need to actually do someone would have to essentially donate a version of those scalars that works for something like MS SQL.
I would like to add that Airbnb is working on to save the heartbeat to Redis, so this may reduce impact on the DB.
Great. All right. Is there a future plan to support NoSQL databases through a pluggable ORM layer like PynamoDB?
Maybe I can take this one. I haven't answered any. No. That's quick. No. Like the relational database in SQL Alchemy is deeply embedded into like how we interact with the database, and rewriting it is a major work, and we haven't planned it.
Okay. Is there going to be any feature for a sub-DAG in Airflow 2.0?
I think there is. There are lots of improvements already for subDAGs, and we are going to make it so that it's just a UI-based concept. Like there are active discussions on the mailing list regarding it. So yeah, there would be lots of improvements on subDAGs, and it should land it in 2.0.
Yeah.
Definitely stay tuned to the mailing list for that. All right, we've got two more. One is a request. Could you please share the link to the Helm chart in the master branch, maybe in the Airflow Summit attendees Slack?
Absolutely.
Awesome. And then the last one I'm seeing is, are there any new features in the backlog about data changing between tasks and DAGs?
I'm not sure I understand that question.
Data sharing, I think I'm supposed to say. So, yeah, I'm not quite sure I understand the question, so I may answer this wrongly. But Bulka's lineage changes kind of makes Airflow a bit more data aware. And also AIP 31, which kind of Tomasz and Gerard worked on, kind of again also makes it a little bit more clear. If you mean something smarter like PyArrow and passing things in memory, we've talked about it, but it's very just kind of, hey, it might be nice. That's all we've got to so far with that one. So no firm plans yet.
And if we got that question wrong and you want to try again asking it in the attendees channel, that's great. All right, I lied. We actually do have two more, and then we'll really be done for real. Are there plans to develop a UI for creating DAGs similar to Logic Apps or Azure Data Factory?
So there aren't any plans to do that in open source core Airflow. There's a couple of possible ones that some people have written, and that's, yeah, like no firm plans yet for open source Airflow.
Yeah, there are a couple of like exporters to Airflow from different systems that people are working on, and they might enable that, but we are not planning to do that in Airflow.
I think there is going to be a Airflow Summit talk about visual DAG editor or something like that.
Yeah.
In short, just search for editors, DAG editors, plugins.
All right, so stay tuned and look in the Airflow Summit program for relevant talks. All right, our last question is why JSON serializable? It's not overly Pythonic and it's hard to verify in parentheses schema. Python has attr and catr as a native construct for a while now.
To say it's hard to verify, well, we've got a JSON schema, so the serialized representation is verified. It's purposely not tightly set what can appear, but it is, there is the JSON schema. It's verified on write and on read. The tests verify it. So there is a schema. It's versioned, so we can upgrade it. Why JSON? Mostly because with JSON column support in MySQL and Postgres, we can do, it opens the door for doing some clever queries in the future. And also, it's nice to be able to look at it in a database. Any kind of binary format just needs that extra hurdle. And we tested the speed of JSON and it's fast enough. It's easy to read. It's human readable. So it's just kind of, it's easy. There we go. And attr and catr can just produce JSON. They're not any special serialization format themselves. They're just kind of a way of converting objects to JSON, I believe.
There's also a note from Kamil that it will be exported by the API.
Oh yes, the serialized representation of a DAG will be one of the things you can request from the API. So yes, that's the other reason, which is the API is JSON, so the serialized representation kind of fits nicely in to the API.
All right, if there are any more questions, do please ask them in the Airflow Summit attendees channel. I'll note that Ash is super speedy and the link to the Helm chart is already there. I'm pointing up because that's where it is on my monitor. It might be a different direction on yours. But yeah, thank you again to all of our speakers from wherever we're located. Let's give them a round of applause. If we're loud enough, maybe they'll hear it. We'll take a quick break now, and the next talk will be at the top of the hour, and it will be about, I believe, secure DAGs. So we hope to see you then. Thanks again for coming, and thank you to our speakers.
Thank you, everyone.
Thank
you, everyone.